the more ways we see a problem, the better we get at solving that problem. Okay, so the more different ways, the more looks, the more visuals, the more situations you can put yourself in to solve a problem, the better you're going to be at it. And so that's why we're going to look at solving some equations now that have decimals in them. Nothing changes as far as how you have to solve equations, right? Getting variable terms on one side, constant terms on the other, simplifying things first, dividing by coefficients, right? All that stuff still works. Doing the same thing to both sides, right? The addition property of equality or multiplication property of equality. Now we just have some decimal numbers. So let's take a look at a couple. So the first one, solve. Remember, solve an equation means find the value of the variable that makes the equation true. So here's the first one. 0.3 times y plus 5.4 equals 22.77. All right? So pause and try it. I'm going to keep going. The first thing I notice is this equal sign, right? Always start with your equal sign. Separate your equation, left side, right side. Now, we have some stuff to do over on the left, right? If you take a look at the left side of the equation, you notice that 0.3 and then something in parentheses, right? To me, that screams distribute, right? Because in the parentheses, you got addition. So we're going to distribute this 0.3 to both of those terms. That gives us 0.3y plus 1.62, right? 0.3 times 5.4 equals 22.77. We didn't touch that side at all. Now we scan it some more. Oh, we have a variable term right there, and we have constant terms on opposite sides. So there's nothing we can do to simplify on a given side. But we're going to have to get this y term all by itself. So let's subtract the other term, minus 1.62. Minus 1.62. And this turns into 0. Equals, let's see, the 0.3y is still there. This stuff over on the right has to be subtracted, and that is 21.15. Now we get to our spot where we have a decimal coefficient times the variable, so we'll divide by that coefficient, 0.3. Divide by 0.3 on both sides. Y is equal to 70.5. Like always, you can take that number, substitute it back up here, and check it. And you should get a true statement. Let's try another one. 283.7 equals 7.79x minus 14.23x minus 10. Okay, stop it, pause it, try it. What do I notice? Here's my equal sign. Separate the left side, right side. There's a lot of stuff on the right side. In fact, I have 3 terms on the right side. 2 of them have x's in them. So I have 2 like terms on the right. I have a constant on the left and a constant on the right. So remember, if like terms are on the same side, we can simply combine them. Add or subtract. Do whatever it says to do with them. That's how I'm going to start. I'm going to subtract 7.79x minus 14.23x. And that is 6.44x. Bring all the other stuff down. 283.7. Bring down that equal sign. Bring down that minus 10. We've already combined these two. Great. Now, the constant terms, this one and this one, they're on opposite sides. Here's where we have to do the opposite thing, right? Plus 10. If they're on opposite sides, you do the opposite operation. Inverse operation. We're going to add 10 and 293.7 equals 600 or 6.44x. All right. Now we get to a spot where we have a term on the left and a term on the right. One term has a variable, the other does not. We always divide by the coefficient, which is the number that's being multiplied by the variable. So 6.44. This one actually doesn't turn out very nice, but that's okay. We're going to talk about how do we deal with that. So let me pull up my calculator and I'll show you. So what we have to do is we have to divide 293.7 divided by 6.44. Let's see what we get. Oh my goodness, that looks awful. 45, I'm going to copy this and paste it right here. I can actually paste that number right here because we're going to talk about what we do with that. Because sometimes when you're doing a problem, you're solving an equation, you get a really big, messy, nasty number. And you need to figure out, how do I actually deal with that? And so, let me bring out this. So this is equal to x. So here's sort of my rule. Right? If a decimal, if your fraction comes out nice, you can use the decimal. If not, then use the fraction. But this is sort of a messy, nasty fraction, and with decimals, and I wouldn't use that either. So this is an appropriate place to round. We sort of have to round it, and so we'll have just a quick little talk about rounding. If your teacher says round to the nearest whole number or to the nearest tenth or the nearest hundredth, you gotta round to the correct decimal place. If not, you can make a judgment call. Rounding to the nearest tenth is generally, a good choice, I would say. It depends on the problem. It depends on other things. You'll learn other rules later in more complex math classes and science classes, possibly, about rules for rounding. For now, we're just going to make a judgment call. So what I'm going to do, I think 45 point, and then one more number seems like close enough. So the way I do that is I'm going to go after the 6, and I'm going to draw a little vertical line here, because I'm going to stop writing numbers at that point. So what that means is my number is somewhere between 45.6 and 45.7. And I have to choose, well, which one is it closer to? And the way we decide that is the number that comes after it. The number that comes after that line. And so if that next number is 0 to 4, then we usually just keep this number the same, call it rounding down. We round it down to 45.6. If that number is 5 through 9, which means we're more than halfway to the next tenth, then we would round up. Because this is a 0, I'm just going to leave this as 45.6, and I'm going to put a little squiggly equal sign, because that means it is approximate to close to x. And so you're not always going to see that. A lot of times the problems will be created so they come out nicely. But if you do, and you're working with sort of decimals and it's going to come out a little messy, sometimes you can make a judgment call on what the appropriate thing to round to would be.